Hey everybody, welcome back. We got Sweeky talking about mixed reality with Xamarin. Take it away.
Hello, hello. Hey everyone, I'm Swiggy. I am actually from the San Francisco office. So if anyone is here, come by, say hi. I'm on the fourth floor. You can heckle me from the window on the side here. So let me share my screen. That should show you my slides. Okay. All right. I am going to start sharing my slides now. Let's get rid of this little puppy on the side here. Oh, here we go. Okay, hold on. I'm going to do that one more time.
You just want to minimize the Skype window as soon as you get there.
All right, let's do this again. So, okay.
Yeah, minimize that.
Let's get you out of the way.
Sweet.
All right, we're in business. Cool. Welcome, everyone. This talk is about mixed reality with Xamarin and Azure Spatial Anchors. So I'm Swiki. I work in Microsoft. I'm in the dev customer advisory team, specifically in the mobile customer advisory team. So what is Xamarin? So I know we had a bunch of talks. David talked about it. Maddie did it earlier today. But just like a quick overview for everyone who's new, who doesn't know what Xamarin is. So basically, Xamarin is the C Sharp offering from Microsoft. It allows you to write C Sharp code and generate native iOS and Android apps. So you have all the power of .NET and C Sharp. So you're sharing code, you're doing all of that .NET awesomeness, and it gives you great native iOS and Android apps. So what that kind of means is I totally stole this slide from Maddie earlier on, so thanks Maddie. But this is kind of what it looks like. So you're writing shared code, shared logic, and all of it in C Sharp, and then the output that we provide to you is a native iOS and a native Android app. So again, just a little sort of how it looks like. So you have all of this, all the system stuff available. You have all the native iOS UI kits available to you to write your apps. Similarly, on Android, you have all of the awesomeness from Android provided to you, but you can just access all of it through C Sharp. All right, so let's get into the meat of this topic. What is augmented reality? What is mixed reality? And how does all of this work with Xamarin? So what is augmented reality, right? So imagine basically that your camera is a giant canvas. So anything it points to is your canvas, and you can throw 3D models at it to generate in any space that is visible to your camera. So essentially, in very simple layman terms, in augmented reality, your every frame your view frame that your camera provides to you is your canvas, and you'll be virtually drawing objects on it within this special coordinate system which is relative to your spatial location. Now, since we're talking about augmented reality, so AR with mobile applications, so we're going to be tapping into each native platform's AR specialization. So iOS provides us with ARKit and SceneKit, and Android provides us with AR Core and SceneForm. So you'll notice as I walk through the demo and I walk through the code, we basically will be piggybacking off all of these, amazing native tools already provided to us from iOS and Android, and we're just sort of adding our own little, magic and goodness to sort of make it all work together. So what is Azure Spatial Anchors then, you'd be asking me? I mean, sure, we already have all these, sort of native options from each platform. Why do you need Azure Spatial Anchors? Well, that's the cool part. So Azure Spatial Anchors sort of lets you share that spatial space that you're creating through the cloud. So basically my idea of this whole thing was I wanted to make my own virtual treasure hunt. I love puzzles, I love games, I love, escape rooms. So I was like, hey, I want to make an escape room sort of virtual puzzle for my friends. So I'm like, so sure, why not? Let me use Azure Spatial Anchors for that. So the idea is you create an instance of your Azure Spatial Anchors. you drop what is called anchors. So there's basically those spatial points, and that's where your objects get drawn, those 3D objects that I was talking about. And then you can share that space with anyone else. You can have it access controlled, and your friends can sort of then see what you are seeing through their respective cameras. So the coolest part about this whole thing is Azure Spatial Anchors as a service is amazing. They have support for native iOS, native Android. You can write Unity apps using it. You can write an HoloLens app using it. And you can also write it using Xamarin. I love Xamarin. I want to use Azure Spatial Anchor. So this is the perfect solution for me. Also, other cool stuff that we'll be doing in this demo is we'll be using Cosmos DB and an Azure App Service to sort of drive some little bit of data that we have to store to help that sort of sharing happen between devices. And it's a sort of a future feature I'm going to add at some point, but it can also sort of add login based control to the system if you want to. So it's a really powerful tool, and it's available to everyone right now. So let's move on. So what I'm going to be demoing today, like I mentioned, since I love puzzles, it's a game that I call Zamagon Hunt. So it's basically like a virtual treasure hunt. And if you want to see the code right now, you can just go onto my GitHub. I'll be sharing all the links again right at the end. So Zamagon Hunt, right? So the idea being there is everyone who's playing the game gets the app, and you have to sort of walk around and search for my lost items and sort of find them for me, as simple as it sounds. So what sort of drives this whole app, right? So there's three basic parts of it. So there's the client app. That's what you'd be giving to anyone playing the game. So they'd be using that to hunt for your virtual objects. There's the admin app that sort of drives the whole, hey, this is where I'm going to drop or hide my virtual objects for everyone to find. And then there's the web backend service, of course, which includes the Azure Spatial Anchor service itself, the Cosmos DB service that sort of drives the whole sharing and storage of the different anchor points. We'll be looking at all of it, so I'm going to go deeper into each of these buckets. So what does the client and admin app look like? So if you go look at the code base itself right now, it is, well, super first disclaimer, it's completely edited off the current Xamarin tutorial for spatial anchors. And that's the beauty of this whole demo. I just wanted to show to everyone that if you want to make your own game, it's not hard at all. The samples are a great starting point. All you have to do is sort of edit it to your need, and you're good to go. It's amazing. So so the client and admin app right now, the way it's structured is, of course, you have the spatial anchors NuGet because you need to use that to talk to the spatial anchor service. We're going to be writing it with Xamarin, and we are going to be using Azure Web Service to sort of host the API that is going to talk to the Xamarin app and the spatial anchors and the Cosmos DB to store some extra data that we need to drive the app logic. So the next thing you'd see that I have broken it up into Xamarin iOS and Xamarin Android. So due to the nature of this app and the fact that it's very, very tied to the native AR kits and AR core provided by each platform, I decided to go with using Xamarin iOS and Xamarin Android natively to write these apps. We could totally have gone with using Xamarin Forms and done native embedding. I just found it easier just to maintain them separately and just not go into the headache of embedding it right now. And each iOS and Android platform further pulls out, as I mentioned before. So we'll be tapping into ARKit and SceneKit for iOS, and we'll be tapping into ARCore and SceneForm for Android. So that's sort of the high-level structure of how the client and the admin app sort of looks like. Let's see what the web services look like. So in Azure, we're going to be setting up three different types of services. So the first off, you'll have to obviously initialize your spatial anchor service. The system is currently in preview, and therefore it is currently free to use. The second is a Cosmos DB. So we're going to be using Azure Tables. So there's a two-purpose to it. The first part is we need to store sort of like the unique key per anchor, so that every object that you're creating, we're going to call that an anchor. So each anchor that you create, there's a unique key associated with it. So that's going to get stored in these tables. And then the rest of the logic that drives my game is tied to the Azure table. And we're going to create an Azure App Service, which will have the API that lets me sort of talk to this table. So yeah, that's literally it. That's all you need to get started with a very, very simple and basic version of a simple treasure hunt. So what does it look like? So I kind of went down two different paths in figuring out how to do this demo. I have both paths ready. So I'm going to right now what I'm going to show is a pre-recorded version of the admin app drawing an anchor and the client app finding an app. If we have time at the end of the presentation, I have my phone hooked up, and in this tiny little phone booth that I'm sitting in, there is one anchor right at my feet. And if you want, I can totally show that to you live, and we can find that anchor right now. So let's have a look at what the admin app looks like. So the admin app's point, let me get this playing. The admin app's point basically is to allow you a way to drop these anchors. So this is AR, so drop me anchors, a bunch of pirate jokes. What you're looking at is me dropping an anchor near my desk in the SF office. I put in a little description for the anchor being dropped because the way my game currently works, the way I have architected it is I provide you a location associated with an ID number. And when you go and look for that anchor, you have to put in that ID number that you're looking for. So anchors away, friends. We have our first anchors dropped. Let's move on and check out what the client app looks like. So in the client app, this is what you'd be sharing with your friends who want to play the game. So they can just go, they'll have to go in. So let me play this video so you can have a look. So they will basically be going in, getting a list of all the potential anchors. So we're going to look for the sixth one that's near my desk, which we just dropped in the last video. And if once they're in the space, it's going to generate the anchor for them and they can find it. So super simple, super easy. Just logically, if you just think about it, it's like very, very straightforward. There's nothing complicated going on over here. So actually, this is not what I want to show. Let me show you what the code looks like. So I'm going to switch over to Visual Studio. All right. So if you clone the repo right now, you'll basically see this solution structure when you open it up. There's, like I said, the three main buckets. So we have our web service, the client app, and the admin app. If you also go and clone in the Azure Spatial Anchor Xamarin sample apps, they kind of look very similar. It look a lot similar to what I'm showing right now because, as I said, I want to show you that it's very, very easy to get started to make simple games like this. And yeah, I basically just modified the sample code right now to make it work for this game. So the first things you will be coming in to do is in the web sharing service, you'll have to come in and put in your Cosmos DB connection string. And that's all the setup you have to do to get your web service going. So right click, hit publish to Azure. You know the process from here. So let's have a look at the two important files that I think are important in this web service. So the first one I like to show you is the anchor controller. So this is basically what sort of drives that API that I was talking about. So we have so there's get anchor async, so with the anchor number. So this is the way the logic is currently driven. So you provide it with an anchor number. Like in the video, I dropped anchor number 6 and I search for anchor number 6. So right now, I don't have it in a very complex state where, just giving a map coordinate or just getting into a space finds the anchor for you, kind of like how Pokemon Go works. But trust me, future versions of this app will definitely have it. And then another important one is the post async. So this is basically what the admin app taps into, and this is what lets you post your description and the anchor key to your Cosmos DB database. So that's literally the only important file in this whole anchor in the sharing web service bit. Super easy, super simple, and like I said, it's exactly the same code from the sharing service in the Spatial Anchors tutorial right now. So huzzah! Thank you, Spatial Anchors team. All right, so the next bit I'm going to show is let me collapse this away. We don't need you right now. I'm going to open up this xamagonhunt.common. So basically, that what's in this common folder is you have to come in here and obviously set up your account key and your service URL for that API, etc. The tutorial walks you through this. It's super easy to get this all set up and going. The next bit is basically these three files. These are basically just wrappers around that URL, the API, basically to sort of send and receive anchors. And all of our Xamarin apps are going to interact with this one common project. So, hey, look at that awesomeness of Xamarin. So you just it has three basic files. One's the actual sharing service, one sends the anchor, and one receives the response. Just simple basic HTTP wrappers around that cool looking web service that we have set up over here. Let's go into where the important stuff comes in, right? So I'm going to close this. Let's take a look at the actual Android and iOS app. So these two folders are the two apps that drive the game. So the admin app is the one that I use to drop me anchors, mateys. And the hunt app is the one that you share with your friends playing the game. That's the one you use to find the app, to find your anchors. So let's take a look at the drop logic. So I'm going to open up Xamarin drop, and let's look at what we have here. So in this, there is a so it's like a demo base controller that sort of drives the whole the view controller that I have right now. In this, the most important thing is I want to if notice this over here. It's called the ACRN view. So this is what I was talking about. So this is the frame that in the demo, if you notice the little dots that were appearing, that's driven by this basic frame. So that's it. This is the camera provided by ARKit, and that's just you pan it around the screen and it grabs all of the features for you. To set this up, it's like you just initialize a new AR scene view. Again, all built in, nothing special has to be set up for this. You have a couple of delegate functions that you need to set up. Let's take a look at what those basically are. So this is basically just the logic that drives the scene view to just tell it that, hey, grab each session, grab each current scene and sort of just process each frame. And it's the one that sort of collects all the data points that, that'll be needed by the cloud anchor service to, sort of update and understand where to draw your anchors, etc. The next bit that's important in this is, let's scroll down a bit. Also, awesome hack. I always forget what are important parts of a code to show. So I just drop breakpoints wherever I think is important. Cool. So the next thing is what is so this is this is the line that sort of starts and configures the AR kit natively in iOS itself. So we had the view set up, and this basically tells AR system that, hey, okay, you can start tracking the system now. Grab this is the plane and just go for it. So this starts the session and gets all of the magic going. Again, you don't need to really understand too much about the system unless you're doing something really, really complicated. But for a very simple version, as the app is right now, this is all you basically need to know. Let's scroll down a little bit more. So this little section over here, like my awesome helper comment tells me, this is what we use to talk to Azure Spatial Anchors. So talking to Azure Spatial Anchors is pretty much straightforward. Once you have the account key and the ID set up, you basically have a couple of delegate events to hook up, things like what happens when an anchor is located, what happens when your anchor session is completed, and all you basically do is just start the session. So initialize it, give it the values that it needs, and just start the session. That's basically it. There's nothing complicated that you need, nothing else complicated you need to provide to Spatial Anchors itself. And all of this comes from the handy little NuGet package that is just the one small reference you need to add here. And boom, that's it, you're done. And then let's see. So, and the last bit that's happening over here is this is how we draw that box that you see on the screen. Again, there's not too much rocket science basically that's happening over here. So we all it's basically doing is grabbing a visual anchor location, and then we create a SEN box, which is an inbuilt geometric shape. So you have basic geometric shapes like boxes and circles provided for you. If you want to create something more complex, you have to you can embed your own personal 3D models that you want to sort of render on the screens. And so I just set up the box, give it a color, and like told, gave it the visual anchor position to generate the box in, and that's it. That's all you have to do. So that's all the place cube it's doing. And the other two things to look over here is, so like I mentioned, this is the admin app. So this is the primary function of this app is just to create anchors. So the way the anchor creation happens is right over here. So all you're doing is making sure is you're basically checking if the local anchor is not null, and it's found a location and all of the information that it needs of the scan space and the actual anchor location. And all we do is we send it over to our spatial anchor session, create cloud anchor async, and we just give it the cloud anchor parameter. That's it. Simple, super easy, super straightforward, very, very easy to do. And this is basically what creates the anchor for the admin app. So this is all we're doing. So since I showed you how the iOS stuff works for dropping an anchor, let's quickly take a look at the client code on how to hunt for the anchor. And this time I'm going to show you how Android works, because that's also very, very interesting to see. So let me close this up. So now we are in this folder, the client folder. So the main purpose of this app is just to locate, correct? So we will be looking at how we're going to locate those anchor points. Okay, so what was I looking for? So this is the activity in Android that drives that camera view, similar to iOS. So let's go down over here. So this is the AR fragment that is the similar to the camera view, the ACRN view in iOS. This is the AR fragment that drives it on Android. Again, super straightforward. Initialize it and set it up to that frame, and it passes and just set it up to provide each frame to spatial anchor so it can collect its required information. And that's it. You're done. You have the camera set up. Super simple, super straightforward. That's the one layer that you work around with. In Android, let's look at what the setup looks like. So we are now using this for just searching. So this app only locates anchor. So the way it does it is, if you remember from the video, I entered in the anchor ID. So we basically take in that anchor ID. And on Android, we have a special separate class setup that does the talking to spatial anchors. So let's pop on over here to see what's going on. So over here, similar, you'll notice this is very similar to how it was set up in iOS. So we're setting up the spatial anchor session, giving it the account key and ID. So this is what it does to start locating it. So depending on what information was provided it from the response, it'll come in here, create what we call a locate criteria, which just sort of has all the parameters it's supposed to be searching for. Like, okay, hey, there's an anchor that I'm looking for, and these are the parameters I need to check, and it starts looking for it. And once it is found, it generates it basically creates, so sorry, this is how the criteria is set up. It's basically coming from the AR fragment itself. Again, you're not doing anything fancy here. You're just giving it parameters it needs. Okay, this is not what I'm looking for. I'm going to go down here, I think is where I have it. So once the anchor is located, it basically triggers the session complete, and that on the Android side will just go in and draw that box on your screen on that AR fragment. So that's literally it. That's all that's happening here. So again, super straightforward. Like I said, I just went in and sort of just edited what was already there in the sample code and sort of just made it work for myself because I wanted a game really bad. And I have Xamarin knowledge, but not that much of spatial anchors knowledge. So sort of found a nice medium in between. So just sort of like a quick recap. What I think is sort of important to sort of remember if you are working in this space. So anchor visual object, you see this word turn up in the documents, is basically that object, like the box in this example. It contains information of the position and the shape that you need. On each platform, because of this mobile app, each platform you tap into its native views and you render it frame by frame. And that is also your canvas on which you place and remove the object. So your spatial anchors layer can be shared between your two apps. As you saw, I have it in a common folder, and that's what you use to send the object to your CloudDB and back. And to create a shared, so you could basically do everything on the left locally on your app on your device, but that's no fun. Why would you want to play a treasure hunt game on your own? That makes no sense. So let's make it a shared experience. So to share the experience, we're going to pull in Azure App Service, pull in a Cosmos DB to share, to have a safe space for all of those anchors that I'm dropping, and then I can share it with all my friends. If you want to take it to the next level, sort of only have you don't want to share it with all your friends, only to your super duper best friends. You can make it ADAL access controlled and only allow specific logins to come in and use your app. And there's a lot of great ways to implement this. You can have a treasure hunt game that talks to IoT devices and that triggers location-based notifications on your phone, to let people know, hey, they're near a potential, treasure hunt point. So you can get very, very creative with this. This is a great sort of starting point, a starting solution to build up on. So yeah, so thanks for listening. And these are all the links. I'll share this presentation as soon as we're done. Probably even put it in my GitHub repo in case you want to access these links. All of these links are on the repo as well. Yeah, and thank you for listening again. I'm going to pause here for questions.
Hey, we are back. I'm moving a little bit because I'm getting ready for the next session.
Oh yeah, no problem.
Hey,
yeah.
so I have a couple good questions here that we can talk about. So
For sure.
Rest Button Pushed ask, I wonder what the benefit of using Azure Spatial Service versus building your own, besides the time to market. Is that the only benefit?
So the major benefit that I see is they handle a lot of like sort of rendering through each frame and collecting all of that spatial data.
Okay.
You don't want to sort of do all that extra unless you're an AR expert. Then please go ahead. Anchors away, maybe
That's
do
right.
it. Yeah, but I just the service is super simple to use, really easy to onboard, and they handle all of that overhead for you, so you can just concentrate on the rest of the architecture of your game. Like, how do you want to interact with it? What does your UI want to look like? Things like that.
Cool, awesome. So, so the next question, and they're one with the big thing is that when using the client, aka the Hunt app, do you need an internet connection, right?
Yes.
Or okay.
Yes, you do. Unfortunately, the service talks to that, Azure service. The Spatial Anchors is an Azure service, so you do need to have it. You could do, like I mentioned, you could do like a native embedded version of it. It'll make your app fatter, and I don't think that's a nice experience. If you do it with online, you can use so many more, sort of services and make the game more interactive.
Gotcha. And that was the next question. Is like, if can you change it to make it work offline? So can you download a certain area?
Oh yeah,
ahead
for
of
sure.
time and say,
yeah,
hey, I'm going to go here.
Exactly. You totally can. You can make a complete offline version of this if you want. I just wouldn't recommend it just because I'd like it to be a little more interactive and rich.
Sure.
And you'll notice right now it's a very basic implementation of what the game can be. I just wanted to give everyone like a starting point, but you can completely adopt it, fork it, and make your own versions of it. Make it fancier, make it cooler. I'll myself be iterating on it as I get time. But yeah, I mean, I can totally see a offline version of this working out 100%.
Gotcha. So another question here that I just saw come up from Wesley Waffles is that can you for the anchors, can you orient them like is it north, south, east, west, or how does that work?
Okay, so great question. So if you go into the Spatial Anchors page, like if I can pull it up right now and not mess up the setup. There we go. All right, so Spatial Anchors, they have a bunch of amazing concepts and frequently asked questions where they explain the whole, how does the location work? How does it understand how to render it? It currently is very localized to the space that you scan. So it's very relative to the carpet versus the wall versus the table, and it works off edges that it finds.
Gotcha.
So it kind of figures out. So it doesn't do like a GPS or a location-based sort of information gathering. It renders all of like these edges and points in this relative to this space, and it's really smart in the sense that I was able to drop an anchor on the table and on the floor, and it treated both differently.
Cool.
So yeah, so the system is a little different on like the traditional ways of sort of like geolocation based. This is a little more spatial based, kind of like how the Kinect sensor works.
Right.
But that's just like a sort of a way to sort of correlate it. It's not exactly the same. But yeah, I'd suggest totally coming into the Spatial Anchors docs page. They have tons of information and like even more guidelines and understanding or how to sort of conceptually you could make more complex and complicated apps.
Excellent. Well, thank you so much, Wiki, for taking the time to talk about mixed reality and Xamarin, how easy it is to get started with an application very quickly. So
Yeah,
thank you for
sure.
that. Everybody, we have our last speaker coming up where we have Rachel talking about making accessible websites for everybody. So what we're going to do, typically, she's actually in the studio right now. So we're going to do a longer pause so we can move stuff around. But please stay tuned. We will be right back.